Awesome. So we are live streaming now, and welcome everyone to ThoughtWorks Hyderabad Geek Night. This is the 70th edition of Geek Night, and we have Shrujan and Shashi with us, who will be delivering a topic on are your enterprise systems resilient enough? Uh, we will be sharing. So me and Akash are the organizers over here, and Akash will be sharing you the links for sign up sheets and the feedback. So do fill in those if you want to talk or if you want to share some specific feedback for us. And we have this Q&A section, so you can utilize that for any questions if you want to specifically ask, and we will be taking up those. So do fill in for those parts also. Great. Have a great organize this thing, and I'll hand it over to Shujan for the introduction. Shujan, over to you. Thank you.
Thank you, Arup. Maybe you could also start sharing the presentation session. Yeah, so I'm Srujan. Started my career in a networks product, developing load balancers and application delivery controllers. Then moved to ThoughtWorks. So been with ThoughtWorks for close to 7 years. Played different roles from developer TL. Now I'm playing the tech principal role for an account, and then also office tech principal for Hyderabad office. So this has been quite a great journey for me in ThoughtWorks. So happy to share some insights I gained or multiple projects that I worked on. So yeah, to you, Shashi.
Yeah, thank you, Srujan. Hello, everyone, and welcome to Geek Night. I am Shashi Kant. Actually, people call me Shashi. I've been with ThoughtWorks for more than 6 years now, and I have overall of 7+ years of IT industry experience. I have worked on various domains. Basically, I'm a full stack developer with a little bit more interest on infrastructure and DevOps side of things. I've worked on a couple of interesting domains. One is in the analytics domain, healthcare. Currently, I'm leading a team in the retail domain. I help a German retailer build them. We are helping them build a marketplace. Yeah, that is about me. Good to meet you all. Happy to share our insights with you all. Over to you, Shujan.
Let's talk about agenda first. Yeah, so in this talk, we are going to talk about what is system resiliency. We'll also try to define what are disaster recovery objectives and how do you define them. And then we'll also cover some of the key elements in any software ecosystem and their criticality, especially in event of a disaster. Then we'll talk about some of the disaster recovery strategies and its implications. And then we'll talk about automation and what we can achieve through automation. Then disaster recovery testing, how do we do it, and what is the importance of testing in disaster recovery. Finally, we'll end with understanding how we can detect disasters in our systems, and we'll have some time towards the end for some Q&A. So this is the high-level agenda we have for today's talk. Before we jump on to the next slide, I would like to have a quick poll on understanding how many of you have encountered or experienced outages in your systems that you've built or that you're working on. Maybe Shashi, you can run the poll. Okay, so we have some decent participation. Let me end the poll. Okay. So I think it's a tie. So it looks like there are people who have encountered or experienced outages in the systems and some who haven't. It's good mix. I think people who have encountered might relate to some of the things and might also think about what could have done differently. for people who haven't done or encountered anything, I think it's probably going to be a good learning. Okay, with this insight, let's jump on to the next slide. What is system resiliency? So it basically talks about the ability of an organization or hardware or a software system to mitigate the likelihood of failures or losses, or to adapt to the changing conditions, or to respond appropriately after the event of the disaster. Right. So this is basically three stages that we're talking about, which is mitigate, adapt, and respond. Mitigate in the sense of we try to avoid even having a disaster. Adapt in the sense of there could be multiple factors which you cannot really think of why a disaster could happen, and how your systems can dynamically react to it and kind of still avoid such a disaster. The third one is about responding when there is actual disaster. So it's not a choice for an enterprise to kind of choose between these three stages. I think all enterprises should have to prepare for three stages, should put efforts in three stages to build systems which can mitigate, which can adapt, and which can also respond. The more you go left to right in terms of implementing the software systems to handle, like to mitigate, adapt, or respond, the more the damage it is. Like if you are trying to respond, the damage is already happened, and it's more impactful for your business, and it also takes a lot of effort to kind of build such systems to kind of recover. Then if there's something that you can do it and mitigate, I think it's better done there because it costs us less and it's lesser damage. Okay, so we will go through each of it in detail, starting with mitigate. Yeah. So we talked about mitigation, which is more or less like the saying, prevention is better than cure. So we're trying to avoid even having a disaster at all in the first place. So some of the things that one can take care or one can do to kind of mitigate this. And this is not an exhaustive list. These are some of the things, like some things that majorly that came to our mind in terms of mitigating such a disaster. One is hardening the systems, which actually means that you uh, kind of close unnecessary ports that you don't really serve on, not use unnecessary libraries in your containers or in your VMs or whichever runtimes that you're using, which will unnecessarily lead to attacks, or kind of define specific firewalls or network rules so that you have a very closed environment of what exactly can be served and who exactly can access. So this comes on the first part, which is hardening of the systems. Then the modern day application development. This is also quite important these days because any small failure in the system, you don't want the whole system to go down, right? You want to reduce the blast radius of the system, isolate it to a specific component or a microservice, we call it. Maybe containerize it so that don't actually have a lot of software libraries in your, say, your runtime. So you just have those exact minimal things that is just required to run your application. It's also easy to maintain this because it's more broken and you know which component is doing what exactly. So it's easy to maintain and it's also easy to fix when there are challenges. Then another thing, important thing is leveraging cloud for undifferentiated heavy lifting. What it means is a lot of cloud providers, or typically any cloud provider for that matter, would have a shared responsibility model in the sense that if I as an enterprise using a cloud, I would own up the data that I store on the cloud and the applications I run on the cloud, right? all the infrastructure related thing, the technical things like electric connections or the network connections and all of that is taken care by the cloud. So this is a very this is a shared responsibility model. So in this way, what the enterprise can do is to focus on generating value than really maintaining the infrastructure, the hardware and stuff like that, right? So if you see the trend in 2021, we have like 67% of all the enterprise infrastructure hosted on cloud, and going forward, I think it's going to be more. So you already see that pattern of how enterprises are moving towards cloud, just to be more safer and mitigate some of these risks of handling or problems in the hardware and handling all of that. Then comes the high availability architectures. Um, Whenever we build any distributed system or any system for that matter, right? Think of single point of failures, consider single point of failures, and build a system that can handle it, right? Which means that maybe looking for availability zones, having distributing your software across availability zones or say regions, or using a global distribution network like CDNs or something like that to make your service more available, right? And the good part is all of this, what I'm talking in terms of building a high availability architectures is something most clouds provide out of the box. So it's again tying back to the third one. So you can leverage the cloud as much as possible. Yeah. So let's take another poll. So how many of you have experience of working on cloud? Because we talked a lot about cloud. Let's see how many of you also worked on cloud. Hey, I think we can end the poll. 80+% of participation. Yeah. So yeah, looks like almost 90% of people here in the talk worked on cloud. So I think then it also makes a lot of relevance for you when you talk about some cloud services and how you could leverage cloud. Yeah. So moving on, we talked about this first phase, which is mitigate, and how what we can do in this phase uh, to even prevent such a disaster, right, or a failure. Uh, let's talk about the second stage, which is adapt. Here we're talking about changing conditions. It could be a lot of peak load or like a lot of load that your services cannot handle. Maybe some attack patterns that suddenly started receiving, and how your system can act when such a thing happens, right, dynamically. So again, this list is not exhaustive list, but some of the key things that one could do. So the first one is horizontal scaling, right? We can never be sure about the exact load that we might receive, and even the exact times when the load would be peaks, right? So the peak times we cannot really know about it. So what we should be prepared for is how we can scale automatically, right? In a lot of cloud solutions, even if you're doing some kind of on-premise with Kubernetes or stuff like that, you have options like auto scaling and how you can configure auto scaling. I think that is one kind of adoption you could have in the scenario of unexpected load, right? The second one is patch management. So this is about ability of the organization or the team to handle critical vulnerabilities. We all know about the recent Log4j vulnerability, right? And how quickly the organization is able to deploy a new version of software with the upgraded library. And this is important because otherwise you are opening up your systems for attacks. So patch management is important, and implicitly what is also important then is, if an organization have to do this right quickly, probably they should be following the modern day application development, right? Like containerization, microservices, all of this, to be able to independently deploy services. And typically for such modern developed applications like microservices, you would have a shorter time to deploy, right? The deploy cycle would be shorter. So that's quite important during the patch management. The next one is distributed workload, which actually means depending on the place the user is trying to access a service, you could distribute your workload across regions or maybe continents, so that you can have more local solution to handle unexpected traffic or unexpected patterns. And this is, in a way, you are adapting to how things are changing. For example, we can take Netflix and assume that our prime time for watching Netflix. I'm just assuming again, as it could also vary from person to person. Maybe in India, the prime time is say 9 to 11. People try to watch a series or watch a movie. In say in Europe, maybe it's from 8 to 10. I believe Europeans try to sleep earlier than Indians. So across, if you look at put it across time zones, uh, the kind of load Netflix would receive, if you look at the around the clock, would be higher in different parts of the world at different points in time. So what Netflix can do is then increase workload in that specific region at that point in time, and then uh, so it is able to cater to the services, and then it would not have any catastrophic effects. Like if there's not enough workload in that region, then the users may try to reach out to a long distance region servers, and then this long connection, there is a long no, no, return time, and then maybe more stress on the servers, and a lot of catastrophic things could happen. And if you also include a sudden peak, and things could really be like really go haywire. So this is one simple technique one could use to kind of adapt to this changing traffic across the globe, across different locations. Then the last one is attack detection. This is more about can the system, the enterprise system, can it understand patterns of attacks, be it say DDoS attack, or somebody is trying to use heavy payloads, or somebody is trying to use different protocols or different kind of connections to kind of bring the service down. So can the systems intelligently detect this? Can it do some kind of rate limiting? Can it block these users? With all of this is adapting to such a pattern. Yeah. So these are some of the tools or techniques, in fact, using which you could try to adapt. And this is again not exhaustive. So we have talked about mitigation, we talked about adaptation, but just by just doing these two things, like having these techniques, like using them would not make our enterprise safe, because like Murphy always says, uh, anything that can go wrong will go wrong. Yeah. So I'll hand over to Shashi to continue further.
Yeah, thank you, Srijan. So we have listened to what Shujan has spoken about, right? There are various ways to mitigate certain things and to adapt to changing conditions too. So, but again, right, as Murphy says, right, anything that can go wrong will go wrong. We can take examples in real lives too, right? So let's say if you think about it, how many of you have heard about the Chernobyl thermal like nuclear disaster, right, which has happened back in 1986? So if you see, right, if you look at it, how it has happened, do you think people when they were actually working at the plant or when they're trying to construct the plant or when they're working to build the plant, have they thought that such a disaster would occur or not? Surely they would have thought about it and they were well prepared. So maybe they could not save many people, if you see, right? And also another example could also be the Apollo space missions, right? So Apollo, the space mission one, which was actually sending 3 astronauts to the moon, it was actually due to some fault at the engine, and then it blasted, and 3 of the astronauts died on the spot, right? So these disasters they occur in everywhere, every world, and it doesn't mean that people are prepared for anything. People just completely depends on the mindset of the people that they need to be aware of that anything can go wrong no matter how much prepared you are and no matter how much you adopt your systems to be. If coming to the IT world, right? Same thing applies also. Just that there could be much more severe revenue losses, or your business could completely go down. So now this becomes very critical to so that your business needs to run continuously, right? If something has happened. So let's talk about few recent examples in the IT industry itself, right? So before moving on to the next slide, I'm going to talk about the Facebook outage, which has happened, I guess, a couple of months ago in October, right? I think most of you might have experienced it when you think Facebook or Instagram, WhatsApp, all of the services were down. Can you guess how much revenue did Facebook lose in those just 6 to 7 hour outage? Maybe you can use a chat to type in people who are attending, and also use the to everyone rather than just hosts and panelists, just to guess a number to see how much it would have cost the revenue for Facebook just for that 6 to 7 hour window. Yeah. I see one chat says 100 million. Yes, you are right, Naveen. So yeah, so the disaster which occurred, right? Facebook outage which happened in October last year, though it lasted for 6 to 7 hours, it costed Facebook around 100 nearly $100 million of revenue. And not just that, during the time the stock price of Facebook has drastically fallen, and it costs Facebook CEO, Meta CEO, right now they call it Meta. So 6 billion, the valuation has been lost based on the stock prices, right? So basically the outage was that some of the network engineers, they were trying to upgrade the border gateway protocols, which caused and kicked everyone out of the system, and thus from all the cloud providers and the DNS resolvers, they were not able to resolve Facebook.com. So this not only just had impact to their systems, but also all other systems worldwide, which were actually using Facebook as a sign-in mechanism, right? You see, what I'm trying to say here is see the impact which is costed just by somebody's trying to misconfigure a network thing, right? And this not only affects financially, but also customer experience, which is takes down, the image of the company goes down. And with this, people, you lose your competition, you lose your business to competition. So if you have seen, right, since WhatsApp wasn't working during that time, people have actually moved to Telegram, Signal, many other apps during that time. So this is all because of just one small disaster. uh, yeah, so you can relate how much many such disasters could have occurred at various across in the, other enterprises too, right? Another smaller example, which is also is, I think most of you are also familiar with this Netflix popular series called Squid Game. So this is a small fact which has actually happened is, so there's a network provider, internet service provider, just like our Jio, Airtel in India. There's SK Broadband in South Korea. They had to pay $23 million as a network fee because they saw a lot of network exchange and the traffic. Just because people started watching Netflix, it has become such a huge network, right? So you see, right, small things. So though the companies are not prepared for things like these occur, and the most importantly, the emphasis is on the mindset of people, that people need to be prepared on such disaster when they occur. Yeah. Uh, Moving on to respond, right? Yeah. So we spoke about two phases of the system resiliency, right? One is the mitigate and another one is adapt, right? So now what happens in case of a disaster, right? What do we do? What happens if we do not do anything? So there goes a saying, right? Left to themselves, things will go from bad to worse. Uh, so by saying that, it also means once a disaster occurs, you need to actively respond to it. We'll also talk about how do we respond and all. But we'll also try to define what a disaster is, right? A disaster could be anything. It is basically an event that prevents your system or workload basically by not fulfilling the business objectives, right? It is termed as disaster, and disaster could occur in many ways. Few of the uh, disasters could be like few of the natural disasters could be like, let's say there's an earthquake or floods in any of the zones where either your on-prem data centers are located or any the cloud providers which you have used, right? Let's say AWS, GCP or something. So during that, all your systems should surely be down. So you don't know what to do. So you need to work on how do you bring them back, deploy it to some other places. So this could be a natural disaster, right? Technical failures are another kind of disasters, which could actually be, let's say there's electricity power grid failures in the region where these data centers are hosted, or your on-prem and within your premises too, where you host your systems and infrastructure. And disasters could also be by human actions. Most of it would usually be by the human actions itself. A recent example, which I was also talking about, right? Facebook's outage. It was by a human action where somebody was trying to change some network configuration and it ended up badly, costing Facebook millions of dollars. It doesn't also only mean that if somebody's changing some configuration, it leads to disaster, but it could also mean that somebody's trying to gain access by illegal means, by hacking into your account, getting sources, and then trying to bring your system down or doing some more malicious activities. So that could also result in a disaster. So now we've learned what disaster means, right? So we will define basically, since we've spoken about mitigate and adapt, we'll now try to respond. And basically the process of preparing and recovering from this disaster is known as disaster recovery. We will look forward into what are the different things which we'll try to do as part of disaster recovery going forward. But before that, we will do a small poll just to understand how many of you have actually, since you have voted, many of you have voted yes for is that you have encountered a disaster. Just wanted to know if you have done any disaster recovery. So yeah. Uh, yeah. If you're not sure what a disaster recovery is, basically you can just vote no. Sure. Okay. I see we can end the poll. I see majority of them haven't neither heard the word or not have worked on disaster recovery. So we can end the poll and share the results with everyone just to see. Yeah, you can see, right? See, there's 8 folks who have not heard about it or anything, so it's 67%. So yeah, going forward, you learn a lot of things to look at what are the things which you do as part of disaster recovery. Stay tuned. Next is, see, now we have learned what a disaster recovery means, right? Basically, it's a process to recover, preparing and planning to recover from a disaster, right? So mainly disaster recovery has 2 main objectives. One is recovery point objective and other is recovery time objective. Recovery time objective is defined as the ability of an organization or the system to bring back to a point where it was actually working, right? The time it takes to bring back and healthy and running. And the recovery point objective becomes basically to ability to restore to a point where the system was actually functional, fully and functionally working. So here, right, if you look at the diagram, right, let's say I'll take just a sample example to explain what it means when it happens a disaster and how you can relate to these objectives too. So if you see over time, let's say you took a data backup of your application at 6 a.m. in the morning this morning, and then after some time, there's a disaster at 12 o'clock in the afternoon, and then you identified it, and then you fixed it, everything, and then it took 6 more hours to fix it, and you fixed it at 6 o'clock in the evening. So now here, your recovery time becomes 6 hours because the disaster had happened at 12, and then your recovery time objective is basically 6 hours. It took you to bring back all your systems. And now when you're bringing back the systems, you're restoring the system to a point here because there is certain data loss because you have not backed up certain things. So you're restoring to a point where the data has been, like, let's say you're restoring back to a point of 6 a.m. So now this data loss is there, and then this is called the recovery point objective. So it becomes very crucial to define these objectives before getting started with any of the disaster recovery sessions or strategies. So few key things to question ourselves is here, how much data can you as an enterprise afford to recreate or lose, and how quickly should you recover, and what is the cost of downtime. Basically, once you question these yourself, basically will help you define your objectives much broader and much better. Let's say if it is business critical and everything needs to be done, how quickly must you recover should also be in minutes, or it could be nearly zero downtime, right? So with these goals, so it helps you design, it helps you establish your objectives. Yeah. So yeah, moving on. So now we've spoke about various phases of system resiliency also, right? And there's also a notion among us for most of the time, right? Whenever we build enterprise systems or any applications which we build in our day-to-day life, we always assume that high availability of a system is high resiliency. That's the notion we jump into every time, but that is actually wrong, right? Because availability is measured over time, and it is, if you see, right, it is measured over time, and I'll talk about MTBF and MTTR. MTBF stands for mean time between failures, which is basically the time between two successive failures, how much time did it take, and mean time to recover, basically how much time did it take for you to recover. So availability, there's a formula you can calculate how your system is available. It is calculated by MTBF by MTTR plus MTBF. This might sound a little complicated, but for the easiest of things, how you can calculate your system's availability is basically number of successful requests processed by total number of requests. And usually it's in terms of nines, like 99.9% or 99.99%. That's how you see across all the large enterprise systems. That's how they promote their activities and they market themselves, right? They say it's 99.99% available. These don't say 100% available, right? Because nobody can guarantee that. And so availability is just basically a small subset, but disaster recovery, the difference is it happens, you recover after a disaster where everything goes down. And here disaster recovery is again into two different objectives, like we spoke about in the previous slide, which is the recovery time objective and the recovery point objective. Yeah, I'll take a pause to see if anybody has any questions. You can please feel free to ask in the Q&A section. Yeah, at any point in time. I need not wait for the last Q&A. So yeah. I will, yeah, sorry. Yes. Sure. Okay. So now, now we'll talk about elements in software ecosystem and their criticality, right? So whenever we talked about, or whenever we question ourselves, right? Let's say, have we experienced any outages in our system, right? Mainly our focus tends towards the production systems itself. But it's not the case, right? Because an enterprise, a large enterprise or a small enterprise, has n number of pieces which it needs to take care of, and not just product systems, right? Let us take a flow to understand what are the different elements which could go wrong and where it can go wrong. Right? For it, I'll also talk about a flow where we use different systems for our day-to-day activities also, right? For example, you're working on a feature and you have to push your code. You've developed a story, you wrote the code, and you have to push it to a version control system. Let's say, for example, GitHub or Bitbucket or GitLab, or it could be any of this version control systems, right? And then there are pipelines which are basically generate the artifacts. Basically, it could be jars or the Docker images, or it could be any other artifacts which are required for your application to run. And then it pushed to Artifactory. You also update your secrets in your secret store, and you also set up your databases and you connect your application. You deploy your application using pipelines, and they connect to the databases over the VPC or the network, basically via setting up the DNS, and uh, within the VPC you deploy your applications too. Yeah. So now what we'll do is we'll also talk about the criticality of each and every system which might happen, right? Let's say if there's a disaster of your version control system. Let's say you push to GitHub, for example, and GitHub is down. So what do you do? Let's say if it's down for 3 hours or 6 hours, it is not as critical as prod system being down, right? Because you still can develop, still can work on your local machines, keep the code handy, and then you can push it once it is up. So the criticality relatively is very low. So here, but that doesn't mean you don't look after and see what is going wrong. If you maintain your own version control systems, as soon as you see it is wrong, you can actually start working on recovering it back up. But again, when I say criticality is low, it's still okay to have some downtime for this, and you don't have to worry too much. Yeah. And then same goes with the artifacts too. When I say artifacts again, right? So if the application is already running in different staging of environments, right? So the test and develop, non-live, whatever it could be. So the application is already running, it has already used the artifacts. If the artifacts aren't available for a while, it is still okay. And you can actually build those artifacts in your local machine and also share it with somebody else if somebody needs it on an urgent basis. Same goes with the secret store. It is already being used by the runtime applications and don't depend on them during the runtime. So they import it while the application is startup. So again, the criticality relatively is much lower. Here we are assuming the secrets are statically updated and used during the application start, and not dynamic connection between the application and the secret store. And same goes with database outages too. If there is some database connection down, so your application is still up, the customers wouldn't notice much of an outage, that application is still up, but there is something which you need to act on, that some of your database is down, you need to bring that back up and on. Comparatively, your application, the runtime, if your app itself is down, right, you need to worry a little bit, because you need to bring it up because end customers might face a downtime. So you need to act upon it and bring it up as soon as possible. You should start working on the recovery part of it. And then we talk about the network outages. It could be the DNS. If your DNS is down, like for example, again, comparing it to the example of Facebook's outage, right? Look, what if somebody's trying to update some of the network protocols? If something is going wrong, you need to act upon it as soon as possible, because it's not just that, it's also the neighboring systems which could also go wrong. Yeah. Also the fact which I forgot to tell about the Facebook outage was during that outage, it also happened that all the ID cards were also not working, so people could not get in or out of the office too. So imagine the impact of the outage which had happened right back in October. Yeah. So again, these are the elements which we think are again relatively which we use day to day, and all of this might have an impact. A disaster could happen at any point, at anywhere, with these respect of elements. Do you see any other elements in your enterprises where something can go wrong? If yes, maybe you can put it in chat. And this is the relative criticality. One doesn't mean low, doesn't mean you don't care about it or something like that. With this, I hand it over to Shujan. But
We take a break, or is it
yeah.
okay to continue?
Shujan, do you want to answer this question, or you were writing something?
I'm writing something.
Yeah. Okay.
Okay, I'm just trying to say, okay, probably this I can just answer it live. So I think there's a question from Akhil asking if when we calculate MTBF, the mean time between failures, we also consider the factor of incidents which is out of human control. So I would say yes, because what happens is availability is mostly historical data. So for example, AWS or GCP, if this say that this service is available at this like this percentage, that giving you a historical data and also uh, estimate of how quickly they could recover in case of a disaster, right? So typically, if they are giving 99.999 availability, which means they would have multi-region backup in multiple locations, and what is the time it would take for them to switch over the network or whatever. So they will calculate all that. So it's typically that. I hope it answered.
Yeah,
Yeah, I think this is thank you from Akhil in the chat. Yeah.
Yeah.
So do you want to continue or you want to take a pause for a minute or so and then carry on?
To take a short break. I don't know, like if people are preferring to have a break, maybe you can also put it in the chat. Short 5-minute break, or if you want to continue, you can just continue.
Folks, you can put in the chat whether you want to continue now or you want to take a pause for 5 minutes or something.
yeah, let's wait for 2 minutes and then see. Or
Okay.
yeah, we are good also.
Let's continue. Okay.
Okay. Yeah, folks are saying continue, so we can continue.
Okay. Cool. So we talked about different stages in resiliency. Then we talked about what is disaster recovery and different elements in on our software ecosystem, which is more critical than other in the event of a disaster. Now, knowing all this, we also need to have some strategies how we can recover. And in the next few slides, we'll talk about some of the strategies at a high level. These are not the exhaustive list of strategies again. So when we kind of define a strategy, what are the factors that we consider? Right? So there are many actually, but just to talk about some important factors. One is definitely the business criticality. Uh, what kind of business you're running, and uh, what is the appetite for the business to go down, right? How long it can go down? What is acceptable? What are the service level agreements, right? The second thing is cost effectiveness, um, which is like all the strategies that we talk about would have associated costs to implement it, right? Also depending on the maturity of the organization or the enterprise, right? If it's a startup, maybe they would have lesser appetite for spending a lot of money on disaster recovery. Unlike a big established enterprise, they would have bigger lot of money probably, and bigger appetite to spend more money on strategy. The third thing is regulations and compliance. This is mostly about say data privacy regulations or specific laws of the land regarding say banking or the specific domain, right? It's also about where to store the data for how long and stuff like that, right? So all of this will come into play when you kind of plan for a strategy. So at a high level, what we'll do is we'll cover 4 different strategies: active setup, warm standby, data replication, backup and restore. So we'll talk in detail each of it. Let's start with active setup. Yeah, as you can see in the diagram, so we considered regions to be a setup, like the granularity at which we are trying to handle the disaster. So you see there are 2 regions, and these 2 regions are both active, right? So on the region in the left would have all the instances, the workload, maybe 100 instances that is serving the users, and probably databases and all other essential components that will make the system serve the requests, right? The exact replica is also there in another region. Now, simultaneously, all the users are being served from both regions. So this is an active setup, and this is how it operates in a normal time. And when there's a disaster, right? Something failed in one region, and uh, the services from this region is not able to serve their users, right? So then, based on some health checks or some other intelligent mechanism, the route towards this region would be closed, and the users would be served only from the other region, which has a healthy software components, right? So, uh, yeah. So looking at it, it's very obvious that if you have to run like extra 100 instances in a different region, which definitely involves a lot of more costs, right? You're just involving more cost just to keep yourself safe, right? There's also this data sync and a lot of other things that could happen, right, behind the scenes. So this is extra cost, and you see that there is no downtime, right? Like the service is always available, right? Even if a region is down, because the another region is up, and users can always hit that. So there's no downtime, probably near zero data loss. That was specifically, there are specific connections that are connected to the region that was failing, and maybe the data in those connection might be lost, but otherwise there's nothing really specific that is being lost, right? Uh, so typically we use such a setup for mission critical businesses. Something, maybe I'm thinking of trading or something like that, right? Few seconds of downtime can lead to billions of losses. Yeah. Yeah. So this is active setup. Let's move to the next strategy, which is warm standby. This looks very similar to active setup, but what you see is the right side part, the workloads, you see it in gray color, which means it is actually depicting that, uh, say, if we need 100 instances to serve the customers, we only probably have 3 to 5 instances up and running in the passive standby region. So this region is not actively serving any users requests. There's only one region that is actively serving the requests. And in case of a disaster, which means there's an intelligent route correction, and the users are routed to the other region, which is passive before. Uh, so this event also triggers, say, scaling up of workloads, and based on the event, you start scaling up, and then you could serve the whole user base that is trying to request. So this you can also see that this also needs some extra cost, because you have all the software components and the workloads, not as much as the previous thing, not exactly full replica, but scaled on the replica. Then there is minimal data loss also, because the same reasons, right? Connections that were already in play during the disaster or the failure. So there might be some data that might be lost in that time. It also has near zero downtime, because the time for switching the route from one region to other region, I think that is when you typically see there's a downtime, and this is also very minimal, negligible one. Yeah, so this kind of strategy would generally be used by, again, business critical operations, but probably not as critical as the previous one. Maybe something that is customer facing and also generating a lot of revenue. Maybe you would want to have such a setup. Okay, so moving forward, we can go to the next strategy, which is data application. Um, so this is, again, taking example of two regions. This is more about synchronizing data. So you don't really think about the other software components and workloads and all that. You only think about how do you synchronize data across regions, real time? So in case of a disaster, you have to bring up these software components up, the workloads up, and then it automatically connects to the database. Then you also switch the route to connect to the new region. This is just for representational purpose. We used Postgres, VPC, AWS, and all that. So this is very, like, you could have a VPC or not. You could use Postgres or some other NoSQL, whichever it is. It is the same kind of thinking that you want to sync data, but then only bring up instances of workload when there's a disaster. So yeah, you see that this would cost us little less than the warm standby because you don't have any, even the minimal standby also. And you would also have minimal data loss. Again, the same case where connections in play, there might be some data that you might lose. There's also minimal downtime. So the downtime is the time during which we're trying to bring up the instances up, which typically containerized, running on cloud if it is most of the cases. So it probably takes minutes to bring back those things. So we use this mostly for less business critical uh, operations. Maybe high revenue probably and not customer facing, or probably there's some service level agreements which can accept such a downtime. So another case I can think of where you would want to use such a setup is there is, like, you use a, like, it's a niche category of service that you're providing, and there's a license that you might need to run in the workloads, right, in the instances. So you typically don't want to have like pay up a lot of money just to have a standby and not using it. So you only want to bring up the instances, and uh, when there's a disaster, and your license cost would only be the same, like same number of instances. Yeah, so moving forward, we can go to the next strategy. So this is the last strategy we'll talk about, which is backup and restore. Yeah, it's quite self-explanatory from what it might mean, which is we would want to back up our data, say periodically, frequently, to a remote location, not the same location where our application is hosted, but somewhere different. And maybe we would also want to do a incremental differential backups so that we don't also increase the size of storage in our remote location. And in the event of a disaster, we would want to copy back this data, restore this into a database or whatever, right? Whichever storage mechanism you're using, and also bring back these applications and configure your network so it's properly solved. So it clearly looks like more process, more time. So the cost is obviously less because there's no setup, right? You only start thinking about it or start uh, having any component running uh, only after there's a disaster in that second region. So in that sense, it's low cost. Uh, Typically use it for less business critical, some back office systems or some internal tools or something like that. There's minimal data loss again, similarly, when there is a connection, the data in the connection and that fails. And there's significant downtime, right? So depending on how big the enterprise is, how many systems you have to bring back, what is the kind of threat you had, it could also take few hours to bring back the whole thing. So one other thing I want to highlight here is if you are using cloud, I think we also talked about in multiple slides. Like usage of cloud would also help us leverage few things. And one of the things that you could leverage is some of these cloud providers also provide some services specifically to backup data, like AWS or GCP. For example, AWS, if you're using relational databases, RDS, there is automated backups, and you can say how frequently it can back up and where you can store it, right? Or if you use DynamoDB, there's also some kind of backup service where you can plan the backup and it automatically backs it up for you and stuff like that. And it's there across cloud providers. And Though I think there are few services for which they still don't have a ready-made service in the cloud, but they're still preparing. So for some such services where they don't have such solutions, could still go ahead and build custom solutions. And this is important, especially to speed up the process. We cannot do things manually, and we need to have proper mechanisms that is already built in to be able to back up and restore whenever there is a disaster. Interestingly, there are also platforms that are coming up which is offering disaster recovery as a service. Uh, I'm hoping in the next few years there would be a lot of disruption there also. Yeah, so let's look at all the four strategies in one glance. Yeah, so this is how they fare in terms of different dimensions. So if you move from left to right, you see that the RTO and RPO, moving from left to right, it is increasing. For example, in active-active setup, it's almost real time. There's the recovery time objective and point objective. And if you move towards backup and restore, it's in few hours. Uh, Similarly, the cost, left side is more costlier, and as you move right, it's less costlier. And downtime, left side there's zero downtime, and if you go right, I think there's significant downtime. Right? So basically, depending on your RTO, RPO, your business objectives, criticality, a lot of these factors, you can think about what could be a sensible strategy that you want to employ for your enterprise. Right? You don't always have to have the best, like the active, right? It also means money. So you need to think about these things. Yeah. So I think I'll hand over to Seshi.
Yeah. Thank you, Srijan. See, as you learned, right, there are various strategies, and if you actually closely relate to the previous slide, right, where just going back, right, sorry, yeah, if you see, right, as go right, the RT and RPO, it's in minutes and hours, right? Here, what happens is the more time you take to bring back your systems and scale up and also connect to databases, restore, it depends that much is the time basically your systems are down, right? And how can you try to speeden up the process to have as much as minimal as downtime, right? So that's where automation comes in place, and automation is the key to faster disaster recovery, right? And as the saying goes, right, the time is money. Here, that's what it is. More the time the system is down for a longer time, the more the losses are, higher the losses are. And another key advantages is, like, as you always know, like manual restoration or manually doing things are always prone to mistakes. So it's always good to automate such tasks. And moreover, when a disaster occurs, nobody might be in, like, a proper happy mode. So people might be in panic mode and not sure what to do. So automation kind of helps in a way to speeden up the process and not deliberately do things which are not supposed to be done, and maybe that could lead to another disaster as well, right? So there are various ways you can achieve the automation. Few of the practices and the things which you can take care of is, one is the infrastructure as code. This has now been a standard practice across various DevOps things, and also many large enterprises are also trying to, uh, uh, promote this infrastructure as code and get it implemented in the projects. So infrastructure code is nothing but basically, if you have heard about Terraform or CloudFormation templates, basically they help you provision all the infrastructure, be it your databases, be it your virtual machines, be it your VPCs, be it your load balancers, with the code. You don't manually go and create in the consoles. So with this infrastructure as code, it helps. Basically, it's all version controlled. You can always go back to a previous state, where if you want the infrastructure to be back a day back or a day up ahead, also you can always port it back so that it's much easier. Another automation which helps is similar to infrastructure as code. We have pipeline as code. Now, most of the just an example, right? In early days and even now, few of the enterprise systems, right? When you're trying to set up a Jenkins pipeline or any other CI/CD tool, let's say Circle CI or Concord CI or GitHub Actions, most of the time what we tend to do is we manually go ahead, click few buttons, create pipelines, set up jobs, and tell what to do in that job, right? And in case of a disaster, right, you uh, think of a scenario where there's nothing automated or there's no code to recreate those pipelines. You have to spend time, which is large amount of time in creating those pipelines again upfront, right? So having this pipeline as code will not only save you time, basically it will set up pipelines with a span of minutes and seconds. And these days, all the CI/CD tools are actually embedded with this feature Python as code. All you have to do is set up, configure few YAML files with the different steps, workflows, or the jobs, and voila, and then you have all the pipelines ready to go. So in case of a disaster too, you maintain it as a code in which you just push it to a certain version control and it picks it, the corresponding CI/CD tool picks it up and sets up the pipelines too. Yeah, another thing which helps is disaster recovery scripts. These scripts could range from anything where you can, so in the previous strategy, right, where we're talking about backup and restore, in case if the cloud provider is not offering any out-of-the-box solution, so you might have to write your own scripts to back up the data and restore the data too. So it could also be these scripts where you prepare upfront and write it, and so that they can be executed in case of a disaster. So the restore scripts, and these scripts could also have, let's say, if you want to set up a new load balancer or auto scale certain things, certain VMs. So these scripts could also include that. So you could have disaster recovery scripts, and these scripts could also be, put it in a way more UI friendly, where if certain people who has not much experience of with disaster recovery too can also look at these scripts and also understand what needs to be done in case of a disaster. Next is the disaster recovery playbooks. Playbooks are mostly like the source of documents where you define all the objectives you define for a particular disaster, and it's also maintained with all the technical and business configurations in one place. And it also tells you what to do in case of failovers, right? So let's say if a disaster has occurred, it tells you what needs to be done as a step-by-step procedure to restore back to the previous storage point to bring it back successfully. So here, with this, if you see, right, with this disaster recovery books, even if somebody's in panic mode, all they have to do is follow the steps and not worry what else to do in case of a disaster. So these are the few things which can be help in terms of automation. There could be many other things also. This is not an exhaustive list. Yeah. So moving on. So what next, right? So let's assume there's a disaster now. I mean, we set up the objectives. We are preparing with our strategy. We have done some automation. What next, right? So next comes disaster recovery testing. So all comes down. How do you want to test disaster recovery, right? And why do you want to test certain things? Basically, it helps you validate all the scripts which you have written as part of automation, be it infrastructure, be it the playbooks, right? It helps you validate whatever is being done. Is it right or wrong, or do you need some changes? It helps you successfully measure the RTO and RPO frequently in case of disaster. It also helps you simulate failover scenarios. I'll talk more about failover scenarios in chaos engineering in a while. And it also helps you, the more often you run disaster recovery, it helps you update your playbooks and keep it up to date as well. Because most of the times what happens is it's not disaster recovery is as a whole process. It's an incremental process, and you keep doing quite often drills to ensure everything is up to date. And in case of a disaster, you not worry of what else is missing. A few things you can implement or try out is, one is disaster recovery drills. Disaster recovery drills are mostly the exercises of sorts where you simulate you assume that something is, your application is down with your infrastructure too. You try to test your old strategy, whatever is done. You try to back up the data. You try to restore the data and spin up new instances and connect those virtual machines to those databases and bring back your systems. So this is kind of a drill. You prepare yourself. You do it very often to also measure your RT and RPO. This also helps you update your playbooks. You can also try to set more gamify these drills. Like, you can set targets every time you do drills. You can put some milestones of, let's say, I want to achieve this kind of disaster. I want to simulate different workflow of, let's say, what if my database is down? What if my application is down? What if my DNS is down? Something like that. So this is one kind of way you can test your disaster recovery. The other thing is more on the chaos engineering part. This is again quite popular in most of the tech firms or the product companies these days, where it's most on the principle of trying to fiddle with the production systems or production-like systems to ensure and build to have that trust. If something is wrong, your systems are capable and enough to bring them back automatically or semi-automatically or by some manual help also. So there are quite a few tools. Netflix built a tool called Chaos Monkey. Facebook does it as an activity as Facebook Storm. And the different enterprises, they do it as Chaos Days. What they kind of do as part of this exercises, they kind of divide them into multiple teams. Let's say there are two teams. One team, what it does is it basically tries to fiddle with some network. Let's say they try to remove the load balancer or change the network rules within the uh, at the ingress layer, or it could be anything, right? And the other team needs to identify what has gone wrong and actually need to fix that system without knowing what has happened. So this becomes more of a gamification of sorts and also helps you test whatever your recovery strategy is with the help of automation and all your scripts. Yeah, so this is about testing disaster recovery. There are other ways also you can test it, but these are the quite popular ways how you can test your disaster recovery strategies too. Moving on, next comes the detection. So this is again crucial. So we have spoken about various things in disaster recovery as a whole, right? We've identified the objectives, we have followed various strategies, we have automated things, we have also talked about how do we test it. But what happens if you're not able to identify that if there's a disaster itself, right? So that means your RT and RPOs would be in huge times, right? So detection is also very much important. So this is like it goes it, right? Early the detection, lesser are the losses or the impact, right? So it's important. It's very important to know that there's a disaster. Basically, whenever your enterprise systems are or the business outcomes are not being met. So there are here are the few ways how you can actually detect that there could be a disaster. One is by enabling real-time monitoring dashboards and setting up those dashboards. These dashboards could vary from all your application dashboards where you can track the database backups or if your system's CPU usage, is it high, low, all the network capabilities and all that. At the same time, you can also track of business monitoring. Let's say even if your technical monitoring is all in good, but your business monitoring, let's say in an example, right? If you are running a retail system, if you have not seen any orders being placed in the last 5 minutes, where if the traffic is heavy, that means even technically, if everything is right, your core business logic is being missed, right? So that also is kind of a detection to help you basically to understand if there's something wrong with your system. Is it a disaster? It helps you identify it. If it is a disaster or not, it could be some smaller bug. So basically, this detection becomes very important, and these dashboards kind of help in identifying those. And now that if you have all the dashboards, but you can't keep an eye on dashboards all day, every day, right? So that's where alerting helps you. You can set up various alerts. I think these days quite popular tools of Grafana, Kibana, or many other tools where you can monitor all these dashboards. And we also come up with functionality of alerting in case of certain anomalies, which you observe across various systems, right? And these alerts can be plugged in to your tools of choices. Like it could be Slack, it could be Teams, it could be your email, it could be your phone. And these alerts basically trigger an action on the front who are actually looking after the systems, right? So once an alert occurs, it becomes an action to look at it, what the alert is, what is there a attack on any of the systems, is there something to be done or something. Another way of detection is also the health checks of the system. These health checks could also be your application health checks, your database health checks, your DNS health checks. These are also, again, can be monitored on the real-time dashboards and can be alerted via the alerting systems. So now, what happens if you have identified something, right? So now, if you have identified there's something wrong with your system, it becomes very much important to declare it as a disaster with all your relevant stakeholders, and also to identify it and declare it not just your stakeholders, but also the neighboring teams whom you are interacting with, or the end users who are actually using. So that's where the last point, declaration and communication, is also very much important in case of a disaster, right? If you have noticed, right, the systems which you use, if it's the Facebook, WhatsApp, GitHub, or it could be any of the enterprise system, they have a separate website which shows actually the health info, health status, and health info of all the services which they provide. And in case of any outages, disasters which they identify or notice, they kind of immediately let uh, uh, share it across social media platforms that their systems are down, and not they inform customers not to panic or not to worry, right? So communication is also the key again here. So as once you identify, you should also let also your teams who are also dependent on you to know, so that they also don't worry, and also prepare themselves to know that something like this has happened. So there are other ways you can also detect, but again, this is most important list you can use to detect any disasters or anomalies within your system. With this, I hand it over to Shujan for the final highlights.
Yeah, so we looked at so many topics, probably so many new terminology, some strategies, some ways we can test and identify a disaster. Let's see if there are some key insights and some key takeaways for you. You can take back to your enterprises you're working with and implement there. So let's start with the first one, which is change in mindset from availability to resiliency. As I think Shashi already mentioned, resiliency is not really just availability. It also includes disaster recovery. And so you need to think beyond setting up a highly available system to have a secure, like to secure your enterprise and its business. Uh, Defining RTO, RPO based on your business criticality and compliance. So I think it again needs some exercise between your business stakeholders, different stakeholders, and then looking at the business criticality, the revenue, or the SLAs that you might have with your customers. I think this exercise should be done to come up with the RTO and RPO. And I think in multiple places we talked about how we can leverage cloud. So yeah, I think offloading infrastructure management to cloud is I think best thing we could do in today's time. And also use managed solutions for backup and recovery if there are any provided by cloud or any other platform you want to choose, instead of you struggling to do this setup of backup and recovery. Uh, like always, automation is a key. We could do all the strategies without automation also, but then the whole point of disaster recovery is how quickly you are able to recover. So the more the automation is, the lesser painful it is, and more profits or lesser the damages, I should say. Uh, Test often and comprehensively. Yeah. So we talked about the DR testing. The more often you test, the more updated your playbooks are, the more ready you are to handle any disaster. And also look at different scenarios, test it comprehensively. There could be multiple threat models. There could be attacker within the team, or some lost credentials, or network attack, or say region is down because of a natural disaster. So think about different scenarios and see if your playbook is handling all the scenarios. And like Sashi said, early the detection, lesser the loss or impact. Yeah, I think we should employ all the tools or techniques to make sure that we are detecting it well in advance, so the losses we can keep it to low. Yeah, so with this, we come to the end of the presentation, and we are open for questions. If there are any questions, we can also put it in the Q&A. You could also raise your hand.
Yeah, folks, please feel free to ask anything or post your questions. I guess there are none. So in favor of time, so for audience, we have shared a feedback form about this session. Please feel free to share your feedbacks, any if you have. And slowly we have moved to the closure of the event. Yeah, sure. So yeah, Shujan, we can share the slides with the audience.
Yeah.
Yeah.
So thanks everyone for attending this talk in the evening after your work hours. Thanks a lot.
Thanks, Shashi. Thanks, Srujan, for your time.
Thanks.
It was great.
Thanks, Ajit. Thanks, Shujan, for
Thank
such
you,
a
everyone.
talk. Yep.
Thank you, everyone.
Thank you, folks. Have a nice evening.
Yeah, bye.
Thank you, everyone. Bye.
Bye.